Hello friends, myself Saurabh Sharma. I am coming with the very good problem of question number 5 from Pathfinder Newton Laws of Motion. I tell you this question is coming from catenary problem. It is the catenary problem. So very interesting problem is given. So what is the wording of this question? I want to read. A uniform rope is tied between a nail A on the wall and nail B on the ground. The rope without touching the ground anywhere assumes curved shape known as catenary. Okay. Tangent at the ends A and B of this catenary makes angle alpha and beta. Okay. With the vertical respectively. Which of the following conclusion can you make? Horizontal component of the tensile force in the rope is uniform. Vertical component of the tensile force increases with the height, and angle alpha can be greater than angle beta. Angle alpha cannot assume a value of 0 degree. Okay, my dear friends. So just listen carefully. What is the question? Suppose this is the curvature like this. And from this curvature, I cut a very small elementary part like this. This is a DL length. So from this DL length here, one force is acting due to gravity. Let linear mass density of rope is lambda. So here it is lambda DLG. Okay. So now I tell you one thing. Here one tension is developed. Let's say it is T1. And here tension is developed. Let's say T2. Of course, this angle is say called theta 1. And this angle is say called theta 2. My dear friends, I tell you one thing. Just listen carefully. If the component of T1 and T2 is, so T1 one component is acting here, it is T2 cos theta 2, and here T1 cos T2 cos sin theta 1, sin theta 2, here it is T1 sin theta 1, cos theta 1, and here T1 sin theta 1. My dear friends, I tell you clearly, one thing you listen. If you see, if this rope is in equilibrium, then horizontal forces are balanced. If this rope is in equilibrium, then net force on the rope is 0. If net force on the rope is 0, so leftward force is equal to rightward force, upward force is equal to downward forces. So my dear friend, on this basis, we can say that it is T1 cos theta 1 is equal to T2 cos theta 2. So you can say that the horizontal component of tensile forces is everywhere uniform. So horizontal component of tensile forces is uniform. So the first option, the horizontal component of tensile forces in the rope is uniform. Of course, it is correct. Question is asking vertical component of tensile forces increases with the height. Okay. So I want to write one by one. Listen carefully. We can say that if this is the length is DL, for better understanding, I redraw again. So this is the catenary shape, and here I am taking this DL elementary part and from this DL elementary part, if this angle from x-axis is theta, so from this angle from x-axis is secant theta plus d theta. So actually theta 2 is nothing but it is equal to theta plus d theta. Some angle is changes, and here theta 1 is theta. So again you can write T1 cos theta equal to T2 cos theta plus d theta. Understood my point? Now I tell you this is T, and of course change and tension is also changed T plus dt, and here tension is called T. So if you can say that this tension have one component is here, it is T cos theta, and here it is also T cos theta, I can write like this, and here it is the tension is T plus dt sin theta. So T plus dt sin theta plus d theta, and here it is, you can write it is nothing but it is equal to T cos sin theta. My dear friend, on this basis we can say that, listen carefully, if this T cos theta is constant, so the T value is K sec theta. Can I write like this? T cos theta is constant, everywhere is uniform, so it is constant. So because of this reason, one force is acting here downward, it is lambda dlg. So as the length is changes, for small variation, the height, the tension is increases. You can check. Understood or not? So we can say that, I can write carefully, just listen, dt tan theta is equal to lambda dlg. Okay, dt tan theta lambda dlg. Okay, sorry, I am extremely sorry, this is a printing mistake. Again I tell you, d times t sin theta, because if you differentiate this equation, what result will come? T sin theta d theta plus dt sin theta. This type of result will come, which is nothing but it is equal to this, and that is called, I tell you, okay, I will give the explanation carefully. Just listen. Upward force is T plus dt sin theta plus d theta, and downward force minus T sin theta is equal to lambda dlg. Okay, I apply this one, it is T plus dt sin theta plus d theta is the sin theta cos d theta plus cos theta and sin d theta. Understood? So as we know, minus T sin theta is equal to lambda dlg. Now please see, if d theta is very small, then cos d theta is equal to 1 and sin d theta is approximate d theta. So I can write T plus dt sin theta plus cos theta d theta minus T sin theta is equal to lambda dlg. My dear friends, you can write T sin theta plus dt sin theta plus T cos theta d theta and plus dt into d theta into cos theta is minus T sin theta is equal to lambda dlg. My dear friend, T sin theta cancel out, and here you can say that this terminology dt is also very small and d theta is also very small. So if two very small component physical quantities are multiplying, so this term is neglect. So if this term is neglect, then you can write the dt sine theta. It is in multiplication, so carefully dt into sine theta plus t into cos theta d theta is equal to lambda dl g. So if you can write, this is the first function and second function, so we can write it is nothing, it is d times differentiation of t sine theta is equal to lambda dl g. Can I say like this for our convenience? So we know very well if we put the value of t is nothing, I calculated here, it is k sec theta. So here I can write t here, t is equal to k by cos theta. So here I can write d times k sin theta upon cos theta is a tan theta. So here tan theta is equal to lambda dl g. My dear friends, k is the constant, so I can write outside. So it is the differentiation of tan theta is equal to lambda dl g. The differentiation of tan theta is nothing, it is sec square theta. So that is called sec square theta is equal to lambda dl g. So this is the one problem. One, we can say that. Now just listen carefully. If theta is increases, understood or not, we can say that length is also increases. Is it clear? So on this basis, if tan theta for tan theta, you can say that theta is increases. Why it is increases? Because L length is also increases. Length is also increases. So on this basis, we can say that in this catenary, this slope and this slope, we can say that alpha can be greater than beta. Understood or not? Means alpha is less than beta. So beta is more than alpha. So what is the answer? Alpha can be greater than beta. It is wrong because this is more, because length is continuously increases. My dear friend, last one, alpha cannot be 0. Of course it is not 0 because it is 0. So tan 0 is 0. Everything is 0. So alpha cannot be 0. Now next point is vertical component of, so alpha cannot be 0. This is also correct. Now vertical component of the tensile force is increases up to height. So you saw the vertical component of the tensile force is always increases. So this is also the correct answer. Thank you so much for watching this video. Bye bye.